Hello grade 11s and welcome back to another video with me, Natasha Barton. In this video we continue with question number 1, and here we are specifically looking at question 1.2. This question says, the sketch shows a block Q of mass 1,5 kilograms. Unfortunately, they have included that on the sketch. They say this block is placed on a rough horizontal surface. The term rough implies that we're probably going to be dealing with friction. They then say block Q is attached to another block P of mass M, by an inextensible cord that passes over a frictionless pulley. So we don't know the mass of this block called block P. The blocks are stationary. Now this is very important information. When you see that blocks are stationary or that they are moving at a constant velocity, it implies that the net force acting on them is 0 newtons. This is very important. We only have a net force that is not 0 when objects are accelerating, which means that they are not stationary and not moving at a constant velocity. They say the static frictional force between the surface and block Q is 15 newtons and the tension in the cord is T. Now we know there's going to be tension or a tension force on block Q to the left, and there's going to be a tension force equal in magnitude to this tension force on block P that is going to be upwards. Now friction is always in the opposite direction to motion. But when an object is not in motion, we say that it is in the opposite direction to which the object tends to move. So if this object could move, in which direction would it move? It would move in the direction of this tension force. Let's say that there was no friction. In which direction would the block move? Towards the left. What is keeping the block where it is actually the static friction force, which is going to be in the opposite direction. Right? So that is where the friction force is going to be. Question 1.2.1 says, what is the magnitude of the tension T? Now please, whenever you have a Newton's law question of this kind, there are two things that I want you to always remember to do. Number 1, whether they say it or not, go and draw free body diagrams for your objects. Number 2, remember to choose one direction as positive, and of course the opposite direction will be negative. We are dealing with vectors, so direction here is incredibly important. So let's go and draw free body diagrams for the system of blocks. Starting off with block P, we're going to label this P, and on the right hand side I'm going to draw a free body diagram for block Q. We're going to do this even though it was not required of us. For block P, we draw a dot because free body diagrams represent the bodies with dots. We know there's an upwards tension force called T. We're not going to call this Ft, but instead T, because the question gave us this symbol. Block P has a mass, and anything that has a mass has a gravitational force acting on it that is always straight down, so include that. Since the blocks are stationary, we know that these two forces are equal in magnitude but opposite in direction. Now we can go on to block Q. Block Q has acting on it a friction force that is to the right. This is a static friction force. It also has a tension force acting on it, which is to the left. Since this object is on a surface, unlike block P, block Q has acting perpendicular to the surface a normal force. So we're going to go and include on this diagram a normal force acting upwards. This block also has mass and therefore has a downwards gravitational force acting on it. In the y direction, so if we draw a Cartesian plane, it would look something like this, and there would be the y direction, there's the x direction. So in the y direction, this object is not in motion, it's not accelerating, it is stationary. So we know that the normal force is equal to Fg. And in the x direction, it is also not moving. So we know that the tension force is equal in magnitude to the friction force. And this actually allows us to answer question 1.2.1. If the tension force is equal to the friction force, right, and the friction force is 15 newtons, then we know that the magnitude of the tension, and therefore the answer to 1.2.1, is tension force of 15 newtons. This question is out of 1 mark, and you're going to be awarded your 1 mark for writing down 15 with the newtons. Remember, no units, no marks, so please remember to write down the N. Now they provide us with new information. They say the mass of block P is now doubled, resulting in the 1,5 kilogram block accelerating to the left. Now, if the mass is doubled, it means the mass of block P is no longer just m, but it now becomes 2 times m. So I'm going to write down next to it 2 times m, or 2m. We know that the blocks are now accelerating. If block Q is accelerating, it means that block P is accelerating as well. And that means that these forces are no longer equal and opposite, so I'm going to remove those symbols. The tension force to the left on block Q is going to be larger than the friction force, and the friction force, as mentioned in the question, is now kinetic friction, or in the information is now kinetic friction. So I'm going to remove the S and remind myself this is kinetic friction, and we're going to put a K down over there, and they tell us that the new friction force is 14,75 newtons. This is a friction force that is only experienced by block Q. Okay, so at this point you would have noticed that I went back and I fixed my free body diagrams to accommodate the new information. Whenever you're given new information, please go back to the free body diagrams, not your answers, but the rough ones that you've drawn, and go and change them, because sometimes we remove forces and the whole situation changes. So please go back and do that. So now we can go on to question 1.2.2. It says, by applying Newton's second law of motion separately to each of the blocks, calculate the magnitude of the acceleration of block P. So we now need to choose one direction as positive, and of course the opposite direction will be negative. When you have a system like the one we're currently dealing with, then we draw a line like this, okay, so to the left and down. I'm going to choose to the left and down. You can see it's a continuous line, if we can call it that. That is going to be my positive direction. And of course, the opposite direction, up and to the right, is going to be my negative direction. Therefore, for block P, the gravitational force is in the positive direction, the tension force is in the negative direction. For block Q, the tension force is in the positive direction, the kinetic friction force is in the negative direction. Choosing a direction in these problems is very, very important. Now we can set up our equations. So we have an equation for P and we have an equation for Q. It is always so helpful for you to label your calculations, not only for yourself, so that when you go back and check your work, you know exactly what you did, but also to help the marker to mark your answers. When it's easier for the marker to mark your answers, you're guaranteed that the person marking your test will not miss any marks by mistake. So write legibly and also keep your work well organized. So now we can write down F net equals MA. We know the objects are accelerating, so on the right hand side we no longer have a 0 newtons. For block P, we're going to say Fg, which is positive, minus the tension, which is negative, equals MA. For block Q, we're going to say the tension minus the friction force is equal to MA. Now for block Q, we have quite a bit to plug in. Firstly, I'd like to remind you that the tension is no longer 15 newtons. It was 15 newtons when the net force was 0 newtons. But since the mass of block P doubled and the system started to accelerate, the tension is no longer 15. So we do not know the tension, but we do know that the friction is 14,75, and this is a new value of friction. The friction is no longer 15 newtons, but is now 14,75. Kinetic friction is always a little bit smaller than the maximum static friction. The mass of block Q was given to us as 1,5 kilograms, and we do not know the acceleration, so we're going to leave that as A. Now let's go on to block P. For block P, unfortunately, we don't know its mass. We know that G, so remember when you calculate Fg, it's mg. We don't know the mass, but we do know the value of G. We also unfortunately don't know the tension. Again, we don't know the mass and we don't know the acceleration. So here we have a problem. We have 3 unknowns and only 2 equations. Is there perhaps a way for us to calculate the mass of block P? Let's think about it nicely. Well, there actually is, and that is exactly why question 1.2.1 exists. In question 1.2.1, the net force was 0, and as a result, the tension was equal to the friction force, F static, not kinetic. So we knew that the tension force was equal to 15. But the tension on this block is equal to the tension on this block. Therefore, the tension is also equal to Fg, the gravitational force on P. So we can say the tension force is equal to mg. 15 for the case where the block was not moving is equal to m times 9,8. We can divide both sides by 9,8 and we find out that the mass of the block is equal to 1,53061. Remember that we only round off right at the end of the problem, and that is measured in kilograms. So we know that the original mass of this block was 1,53061 kilograms. But remember, the mass doubled. So now, in order to calculate the new mass, we're going to say m new, the new mass is equal to 2m, which is equal to 2 times 1,53061. So we multiply that by 2, and we find out that the mass of the block P, is equal to 3,06122 kilograms. So that is the mass of block P. So now we know its mass. We can calculate Fg acting on it by saying 3,06122 times 9,8. So we multiply by 9.8 and we find out that the gravitational force acting on this block is equal to 30 newtons. Okay, it is actually 29,99995, which when rounded off to 5 decimal places will actually give us 30. So I'm going to go ahead and substitute 30 in over here. Minus tension equals MA. So in the place of mass, again, we have 3,06122 times the acceleration. So now we fortunately have 2 equations, 2 unknowns. We don't know the tension here and there, but we know that they're equal in magnitude. We don't know the acceleration here and there, but we know that it's exactly the same for the whole system. So the question asks us to calculate the acceleration of block P. We therefore are going to make T the subject of the formulae. So on the left hand side, if we move over the 30 and then divide by negative, we're going to have negative 3,06122 acceleration plus 30 is equal to T. That is going to be our equation number 1. And on the right hand side for the formula for Q, we have that the tension is equal to 1,5A plus 14,75. This is going to be equation 2. Now, since the tension is equal to the tension, we can go ahead and solve simultaneously by saying negative 3,06122 acceleration plus 30 is equal to 1,5A plus 14,75. We can move over our accelerations, move the constants to one side, divide by the coefficient, and we find out that the acceleration is equal to 3,34 meters per second squared. And that is the final answer to this question. So it's quite a lengthy working that we had to do, but it is out of 6 marks, and those marks are going to be awarded as follows. So firstly, you're going to get a mark for your substitution in order to find the original mass of block P. You're then going to get a mark for stating that the net force is equal to mass times acceleration. That is your formula. You're going to get a mark on the left-hand side for 30 minus tension, and a mark on the right-hand side for 3,06122 acceleration. If instead of substituting in 30, you subbed this in, you're still going to get your marks. And then for Q, you're going to get your mark for your substitution. So far we are on 5 marks. And then lastly, you're going to get your mark for your final answer. So grade 11s, it does not matter which method you use to solve simultaneously. Some people substitute, some people put one equation on top of the other. It's completely up to you. Provided you do it correctly, you're going to get your final mark to this question. Please do not forget the correct SI unit, or you're going to be penalized. Remember, in the next problem, or in the next video, we're going to continue with question number 1. Specifically, we're going to take a look at question 1.3. So please be sure to join me there.